Chapter 8 is about hypothesis testing. It is part of inferential statistics, and in Chapter 7 we used to estimate a population parameter, such as estimating a population parameter with a confidence interval. And in Chapter 8 we will test a hypothesis or a claim about a population parameter. So briefly, a hypothesis is simply a claim or a statement about a property of a population. And a hypothesis test, or test of significance, is a procedure for testing a claim about a property of a population. And we'll have more specific definitions here in just a moment. We begin with these steps in hypothesis testing. And number 1, a claim is made. Number 2, evidence, usually in form of sample data, is collected in order to test the claim. And then we analyze the data in order to support the claim or to contradict the claim. So here's a definition. A statistical hypothesis is a statement or claim regarding a characteristic of a population. A hypothesis test is a standard procedure that is based on sample evidence, and probability for testing the validity of a claim about the population. So one is the statistical hypothesis, and then the hypothesis test. So we need to keep these two things in mind, that they're different. Now we come to two very important definitions. The null hypothesis, denoted this way, and is read H naught, is a statement to be tested. The null hypothesis is assumed to be true until evidence indicates otherwise. Really, really important statement about the null hypothesis. The other definition is the alternative hypothesis, denoted this way, and it's read H1, is a claim to be tested. So the claim we are trying to gather evidence for to determine the H1 alternative hypothesis. H1 is sometimes called the research hypothesis. The research hypothesis. So in this chapter, there are 3 ways to set up the null hypothesis and alternative hypothesis: equal versus not equal. Not equal. There would be a two-tailed test, a two-tailed test. In other words, H naught, the parameter, is equal to some value, and the alternative hypothesis, H1, the parameter is not equal to some value. The second one is equal versus less than, and this is a left-tailed test. In other words, H naught is the parameter is equal to some value, and then H1, the parameter is less than some value. And the third one is equal versus greater than. And this is called a right-tailed test. A right-tailed test. Here, h0 is, the parameter is equal to some value, and h1, the parameter is greater than some value. In other words, the null hypothesis h0 is always the statement of status quo, which means no change, and contains a statement of equality. If you look at the previous examples, you notice h0 is always with an equal sign. Okay? And the null hypothesis is the one that is assumed to be true, is assumed to be true, until we have evidence to contradict it. Until we have evidence to contradict it. And then H1, the claim that we seek for, is always the alternative or research hypothesis H1. So let's look at a simple example. In 2008, 62% of Americans 18 years and older volunteered their time in some form of charity work. A researcher believes this percentage is different today. So our null hypothesis H0, P is equal to 0.62, or 62%, and the alternative hypothesis H1 is different, so that means P is not equal to 0.62. So P is a population proportion, and this is a two-tailed test. Two-tailed test. The next example says in June 2001, the mean length of a phone call on a cellular telephone was 2.62 minutes. A researcher believes that the mean length of a call has increased since then. Okay, so here we are dealing with a population mean, mu. So our null hypothesis is mu equaled 2.62 minutes, and H1 is mu is greater than 2.262. So again, that's about the population mean. Population mean. And this would be a right-tailed test. Right-tailed test. Now we got to be careful here. We can never prove the null hypothesis. We can only say there's not enough evidence to contradict it. Okay? Very, very important detail here. We don't prove a null hypothesis. When you wish to show evidence to support a claim, you set up a claim in the alternative hypothesis. So the alternative hypothesis H1 is called the research hypothesis, because that's where we analyze the data. Let's look at an example here. Critics say the average or mean study time for community college students is less than 10 hours per week. So this is less than, so that's our alternative or research hypothesis. H1 is mu is less than 10 hours per week. And therefore our null hypothesis, H naught, is mu equals 10 hours per week. Again, it's about mu, the population mean, and of course it's a left-tailed test. The next example is again about identifying the null and alternative hypothesis. And it says, to study current trends in college economics, a research group plans to gather data to determine if more than 50% of community college qualify for financial aid. So, again, we begin with our research hypothesis, H1. And so that is, of course, a population proportion, that P is greater than 0.50, 50%, and therefore we know that our null hypothesis, H naught, has to be P equals 0.50. So this is about a population proportion, P, population proportion, and this would be a right-tailed test. And I'm sure by now you've already noticed that in whatever direction the inequality symbol points, that's where the tail is. So right-tailed, left-tailed, it's an easy way to remember this. In the next example, it's about the voter turnout. The percentage of registered voters who actually vote is lower than last election's turnout of 63%. So less than indicates that our alternative, our research hypothesis, says that P, or claims that P is less than 0.63, 63%, and therefore our null hypothesis is P equals 0.63. And this, of course, would be about a population proportion, and it is a left-tailed test, left-tailed. So let's go over some basics. H naught, our null hypothesis, always includes equality. H1 sometimes is called the research hypothesis. H naught is assumed to be true until data contradicts it, and H1 is the hypothesis to prove its case. It has to prove its case. And then H1 determines if the test is right-tailed, left-tailed, or two-tailed, and H1 is the hypothesis we write the conclusions about. Okay, the last point is pretty critical because we don't just want to come up with the answer about H naught or H1, but we want to write about the conclusion. So here's about stating conclusions, and it's based on evidence. So let's say here's our H naught mu equals 2.62 and H1 mu is greater than 2.62. So if the evidence is strong, the data does not provide evidence to conclude the alternative hypothesis, or does provide evidence the alternative hypothesis, H1. Okay? That's when the evidence is strong. If the evidence is not strong, the data does not provide enough evidence to conclude H1. So you may want to spend a little time thinking about these two statements, about strong evidence and evidence that's not strong, and how that relates to the H1 to the alternative hypothesis. So let's look at an example and how to word the conclusion. So here in June 2001, the mean length of a phone call on a cell phone was 2.62 minutes. A researcher believes that the mean length of a call has increased since then. And so suppose the sample evidence, the data results, in other words, that the sample mean is 5 minutes, indicates that the null hypothesis should be rejected. State the wording of the conclusion. So in other words, we reject the null hypothesis. We reject. And so we say yes to the alternative hypothesis. And here's how we say it. So in conclusion, we write, this data does provide significant evidence to conclude the alternative or research hypothesis H1. In the second part, the B part, suppose the sample evidence, in other words, the data results, the sample mean is 2.6 minutes, indicates that the null hypothesis should not be rejected. State the wording of the conclusion. So first of all, we fail to reject. Fail to reject H naught, and here we don't have not convincing evidence. Not convincing evidence. So here's how we write our summary statement. So here's how we can write our conclusion. This data does not provide significant evidence to conclude the alternative H1. So here the emphasis does not. In the previous statement it does provide, but here it does not. So here's a pattern that you may want to copy for future use at the whatever percent level of significance that was required. The data either does or does not provide significant evidence to conclude, and then here what follows is whatever is written in the alternative hypothesis H1. Okay, so there would be a pattern you can use for stating your conclusion. Let's go back to a previous example we discussed. In 2008, 62% of Americans 18 years or older have volunteered in some form of charity work. A researcher believes that this percentage is different today. A. Suppose the sample evidence data results that shows sample proportion as 80% indicates that the null hypothesis should be rejected. State the wording of the conclusion. Well, first of all, we reject, based on the data, reject the null hypothesis. Reject null hypothesis. And so this would be a yes. And here's how we state this. So here's what we can write for the conclusions. The data does provide significant evidence to conclude the percentage of adult Americans doing charity work today is different than 62%. because the alternative hypothesis was proved to be true from the data. Now let's look at the next part. Suppose the sample evidence with data results show the proportion of 60% indicates that the null hypothesis should not be rejected. State the wording of the conclusion. So in other words, here we fail to reject the null hypothesis. In other words, there's not convincing evidence. Not convincing evidence. So here's how we can write our conclusion. So here's how we can write our conclusion about failing to reject H0, and there's not enough convincing evidence to make this true. So we can write, the data does not provide significant evidence to conclude the percentage of adult Americans doing charity work today has changed from 62%. So again, by following the pattern that was written in a black box here, you can come up with a good statement, and I'd really recommend you practice this, because writing the conclusions is integral to the hypothesis testing. Let's talk about the 4 outcomes of hypothesis testing. And that's in the context of something that you're familiar with, or at least it's easy to relate to. So the current status is either the car, you're considering buying a used car, and the current status is the car is reliable, or the car is not reliable. And then you either decide to buy the car or you decide not to buy the car. So there's a total of 4 decisions. So there are 2 correct decisions. You decide to buy the car, you buy the car when the car is reliable, when the car is reliable. And the other correct decision is you don't buy the car. You don't buy the car when the car is not reliable. When the car is not reliable. So intuitively, that makes a lot of sense. Now, the error decisions are, do you buy the car? You buy the car, and the car is not reliable when it is not reliable. And the other error decision would be you don't buy the car and when the car is reliable, when it is reliable. So which error do you think is the worst type of error for you? Well, it would be this one here. In other words, you buy the car, you spend your money, but it's not reliable. So that would be the worst type of error for you in this particular situation. Here's a similar example. Suppose you're in charge of hiring a new employee for your company. The current status is you either have the applicant is qualified for the job or the applicant is not qualified for the job. There are 2 possible decisions. You decide to hire him or you decide not to hire him. So the 2 correct decisions would be you hire him, and he is qualified. He is qualified. Of course, the other correct decision would be you don't hire him. You don't hire him when he is not qualified. He is not qualified. And what would be the incorrect decisions? Well, the incorrect decisions would be you hire him, you hire him, you hire him, and he's not qualified. Or the other incorrect decision is you don't hire him. You don't hire him when he's qualified. Again, which error decision is the worst type of error for your company? Well, when you hire someone who's not qualified. Here, I mean, that can cost you a lot of money. If you don't hire him, sorry, even though he's qualified, well, you missed out on a good person and maybe somebody else gets him. But this, the first one, that could really cost you money.